Hello, my name is Samuel Carlos from the course Statistics and Probability for lecture section 1, discussion section 8 for the fall semester of 2020. And today we're going to be talking about biased and unbiased estimators. What are estimators? An estimator is a rule for calculating an estimate of a given quantity based on observed data. This could be things like the mean of a data set or the median. Estimators can be biased or unbiased. Biased means the results are not in line with the estimator and the skew is present in the results. Or not in the results, but in the estimator itself. This would most likely mean the estimate is wrong. Unbiased means the results are as expected with little asymmetry. This is the kind of estimator you want the estimator to align with the results. An unbiased estimator. An example of an unbiased estimator. So let's say we have a deck of 10 cards and each of the cards are numbered from 0 to 10. We would then pick 2 cards from the out of random and average it out. And we do this 25 times. We can calculate an estimate by taking the average from 0 to 10, which comes out to 5. So with this graph we can see the results of 25 tests. We also see the graph is not perfectly symmetrical, which is to be expected with the low sample size. If we were to draw a symmetrical hill with the mean centered around the hill, it would align with our testing and align with our estimate. So right here we see our estimate would be 5, and a hill centered around would align with the results we have here. So these results are unbiased with the estimator. The estimate is unbiased with the results. Since the results are reasonably around the estimate, the graph lines reasonably with the hill placed at the estimate. A biased estimator. An example of a biased estimator. Let's say we use the same results as last time, but this time for our estimate we use 3 because it's our favorite number. It's because it's a favorite number of mine. We again use the estimate and draw a hill around it and see how it compares with the results. We can see how the results are skewed with the estimation, and to be more precise, the hill shows an underestimate of the mean. Biased versus unbiased. We want our test to align with our estimate since the estimate will be the best answer since we will not be able to obtain the exact answer in most cases. A biased estimate with no support behind it will lead you nowhere, while an unbiased estimate will lead you closer to the answer you are looking for. What do we want in an estimator? We want our estimator to be unbiased. This means that our estimates are in line with the results. The estimator should come from some mathematical origin, such as the mean or median, or from the testing itself. We also want our estimator to be consistent. And as the sample size gets larger, our estimator should still be in line and be as precise as possible. What is the point of an estimate? Sometimes we want an exact number, but there are situations where getting the data would be nearly impossible. For instance, let's say we want to find out the number of average pets in a single household across California. There are about 14 million homes across California, and getting information from every house would be tedious and nearly impossible. So instead of an exact number, we need the best guess we can get. This is where estimates come in. Estimates can help us get a number that is close to the exact, and the higher our sample size, the better our estimate becomes. And in this scenario, we would want to be surveying all across California rather than just one town. And we want our surveying to be as random as possible all across California. The value of estimators in the real world. Estimators are used across all fields: chemistry, mathematics, and computer science, to name a few. Every field that requires testing with a sample size could use estimators. Across these fields, an exact number may be unattainable, and the next best thing is an estimator. An unbiased and consistent estimator can help people get the answer they were looking for, even when there's an obstacle in the path to the right answer.